Welcome to the overview of real estate finance and investments. First of all, we'll have to establish the objectives for this course. The main goal of this module will be to introduce you to the subject of real estate, whereby by the end of this course, you'll be able to conversantly define the basic legal concepts of real estate and also have a clear understanding of mortgages and notes. So let's get started. First of all, we look at the basic concepts. So real estate is a term used to mean land and all things attached to it permanently. Personal property, on the other hand, refers to all intangibles. And by intangibles, we mean things which you cannot be able to hold physically, and all movable things such as cars, stocks, machinery, patents, etc. Then, real property refers to the ownership rights associated with the real estate. Property rights are also defined as the right to possession, use, enjoyment, and disposal of property. Another basic legal concept is interest in property. This is the interest created by owners of real estate who pledge and encumber property in order to achieve an objective. For example, one may pledge real estate and may also create easements in terms of giving access to their own property once they have the interest in the property. The term estate means all that a person owns. So this is commonly used whereby you find people referring to their estate. So this includes both the assets, physical and intangible assets that a person holds and has a right to. The term estate in real property is used to describe the extent to which rights and interest in real estates are owned. There are two main classifications of real estate. So the first classification is based on rights. So hereby we'll have estates in possession. This refers, or rather, estates in possession is one that entitles its owner to immediate enjoyment of the rights of the estate. Then we have estates not in possession. In this case, one does not convey the rights of the estate until some time in the future. For example, reversions and remainders. The next classification of real estate is based on possession and use. Hereby, we have freehold estates. These last for an indefinite period of time, connotes ownership. For example, fee simple estate and life estate. We also have leasehold estate. This expires on a definite date, implies only right to possess and use. For example, estate for years and estate from year to year. Now we'll have a look at notes and mortgages. Notes and mortgages are the two legal instruments used frequently in real estate financing. A promissory note is a document that which serves as evidence that debt exists between a borrower and a lender and contains the terms under which the loan must be repaid and rights and responsibilities of both parties. The main loan provisions are as follows: amount borrowed, rate of interest, installment, due dates, and number of payments, maturity date, reference to real estate serving as security, loan assumability, non-recourse clause. Mortgages, on the other hand, entail a mortgage document, which is created in transaction, whereby one party pledges real property to another party as security for an obligation owed to that party. Interests that can be mortgaged include fee simple estates, life estates, estates for years, remainders, reversions, leasehold interest, options to purchase real estate, funds for taxes and insurance, charges and liens, preservation and maintenance of the property, transfer of property or beneficial interest, due on sale clause. Right of entry, which is also referred to as lender in possession, subordination clause. Well, we also have other source of financing. So other source of financing includes seller financing. This happens when a seller is willing to take back a mortgage as part of full payment of the purchase price. Mortgage default results from the breach of the mortgage contract, especially the failure to meet an installment payment, and this may lead to a foreclosure. Alternatives to foreclosures, or what are commonly referred to as workouts, include the following: restructuring the mortgage loan, transfer of the mortgage to a new owner, voluntary conveyance of the title to the lender, a friendly foreclosure, a prepackaged bankruptcy, or finally a short sale with the lender agreeing to a sale price less than the loan balance. Now, with that, you have a clear understanding of the legal framework related to real estate and also related to promissory notes and mortgages. We'll also provide a document having further details of all the terminologies included in that first section. Now, in this next section, we look at time value of money. First, we'll have a look at compound interest. Any compounding problem has four basic elements: an initial deposit or present value of an investment of money. It also has an interest rate, time, and value at some specified future period. The future value is calculated by multiplying the present value and an addition of the interest rate raised to the number of years. So this calculation can be illustrated through the formula here below. So let's say you have an interest rate of 10%. In this case, for you to get the future value of 100 Kenya shillings note today, you'll simply multiply the 100 multiplied by 1.1 raised 1. So since it's 1 year, it will be 100 times 1.1. If it was 2 years, it will be 100 times 1.1 raised to 2. With that, you get your future value. Other compounding periods usually occur when the loan is compounded based on the number of periods. So you can compound your loan monthly, quarterly, semi-annually, or annually. In such a scenario, you'll have to divide your rate by the number of periods through which it's being compounded, and you'll have to raise it to a multiple of the total number of periods. So this is illustrated in the formula here below. To have a clear understanding of this, we'll have a look at this practical example where we'll compute the future value after 1 year of 10,000 Kenya shillings deposited at an annual rate of 6% compounded monthly. So to do this in Excel, we'll have first to note the deposited amount, which was 10,000 Kenya shillings. Then the annual rate, which was 6%. So for the purpose of this example, since this interest is being calculated on a monthly basis, so we'll get our monthly rate. So to do this, we'll simply take this, which is the 6%. We can also indicate this first in the right format of the percentage, which is 0.06, which is 6 over 100. Then the monthly rate, for us to get the monthly rate, we have to divide this by 12. So this is the monthly rate. So since it's a 1 year period, so we need to note that total, or rather, let's write here 1 year. For years, we have 1 year. So total compounding periods will therefore be 12, which is simply 12 times 1 year. So for us to get our future value, we'll take the deposit, which is the present value, and multiply it by 1 plus our monthly rate here, and raise it to the number of periods, which in our case is 12. We'll find that our future value will therefore be 10,616 and 77 cents. We can also round this off to make it more relatable. So now that's the future value for this example. Now let's look at effective annual rate. So you might have already noticed that in the event where compounding is done more than once per year, you'll find that the rate will keep on varying. So for us to get the effective annual yield, we are able to do this by first subtracting the present value from the future value, and that difference we then divide it by the present value. So for this example, we'll be able to look at calculations based on different compounding intervals. So for a nominal rate of 6%, in the event that it's compounded annually, the effective annual rate still remains, or rather the effective annual yield. Pardon for that. This is the effective annual yield remains at 6%. In the event that you're compounding it semi-annually, you'll find that the effective annual yield increases to 6.09. For quarterly, this is done 4 times. We get an effective annual yield of 6.14. And for monthly, we get an effective annual yield of 6.17. And daily, we get an effective annual yield of 6.18. So the implication of this means that the more the compounding intervals, the higher the effective annual yield. So going back to our example, the deposit of 10,000 Kenya shillings at the annual rate of 6% compounded monthly, we were to get 10,616.78, which is equivalent to the gain of the annual, or rather the effective annual yield of 6.17. So it's obviously 6.17 and other decimal points thereafter. Now we can also run this practically and show it on the Excel sheet. So now let's have a practical explanation of the effective annual yield. So first of all, we need to specify the present value. So for this example, let's still work with the 10,000 Kenya shillings. Then we need to specify the annual rate. So for the purpose of this example, let's still continue with the 6%, which is 0.06. Now, I want us to be able to calculate the different future values based on the compounding periods. So here we can say compounding periods. So for 1 year, that's one compounding period. Quarterly, or no, semi-annually, that's twice an year. And quarterly, that's 4 times within a year. And monthly, that's doing it 12 times. And daily, we have 365 compounding periods. That's a day. So with that being said, we need to be able to remember that the formula of getting the effective annual yield, first we need to calculate the future value. Now, in this case, let's calculate the future value. So the formula for the future value, if you can recall, we need to multiply the present value by 1 plus the annual rate divided by the compounding periods raised again to the total number of compounding periods. So for this example, we're still working with the same 1 year. So for this example, for us to get the future value for the annual, we'll get the present value. So let's lock in this cell to make it easier for us to populate this. Then we multiply this by 1 plus the effective annual rate, divide by the compounding periods. So in this case, it's still 1. And then we raise this to 2. So since it's 1 year, the number of years still remains 1 times this. So for the purpose of this example, we still raise it back again to this. So there seems to be an error here. So what's the error? Yes, I believe that now that's correct. So based on this formula, this is the advantage of using Excel. We can simply drag it down, but we also need to lock this cell here in our formula. So for that, we'll just add a $sign so that once we drag down the formula, it does not change. So these are the future values. Then our present value still remains the same in this case, which is the 10,000 Kenya shillings. So let's just add it here. Then we also had to subtract the future value from the present value. Is the future value minus present value. So we take this and subtract this. Let's drag it down for the others. Now the effective annual yield, let's just write it in full. Effective annual yield. To be able to get that, we'll simply take this difference and divide it by the future, or rather by the present value. So let's just lock that again. So in this case, you can be able to see practically how the effective annual yield continues changing over time. So in percentage format, you can be able to view the effective annual yield since it's indicated as a percentage and not as decimal points. So the more the compounding periods, the higher the effective annual yield. So the event that you're paying out a loan, if it's being compounded more regularly, it means you end up paying more. If it's an investment property, if it's being compounded more regularly, it means that you're earning more. That's the clear explanation of the effective annual yield. Now let's look at present value. When determining how much should be paid today for an investment that is expected to produce future income, or rather produce income in the future, you must apply an adjustment called discounting to income received in the future to reflect the time value of money. The concept of present value lays the cornerstone for calculating mortgage payments, determining the true cost of mortgage loans and finding the value of an income property. The formula of calculating the present value entails dividing the future value by the interest rate factor, whereby you add 1 plus the rate raised to the number of periods which you're compounding. So let us do a practical example. For example, how much should an investor pay today for a real estate investment that will return 2 million at the end of 3 years, assuming the investor desires an annual rate of 15% on the amount invested? So for us to do this on our Excel sheet, so the 2 million here will be the future value. Then another important thing to note is the desired annual rate. So that we'll call our annual rate, which is 0.15, the 15%. So the period here is 3 years. This is the compounding period. So what we're asking ourselves is how much should be invested today, which is the present value. So for us to be able to do this, we take the future value and divide it by 1 plus our annual rate and raise this to the number of compounding periods, which is 3 in this case. So this is the amount which should be invested today, or rather which will be used today if the investor expects to earn this return in the future. So I hope that was clear. You can also try with other different examples and see for yourself. I've actually also noted that here I inserted 200,000 instead of 2 million. So the advantage of using these formulas is that now once I change one thing, I can simply get the answer directly without having a need to rewrite the formula again. So let's add this so that in future we reduce the mistakes which we make. So simply now, once I change any value here, let's say the annual rate, the expected annual rate was 20%. So now my present value is 1.15. If it was 10%, there. If the period is changing, let's say I expect this after 2 years or 3 years. If it's 2 years, now you can see the present value adjust automatically. Now let's look at the present value of an annuity. An annuity refers to regular payments over a set period of time. And another important thing to note, these regular payments are in most cases constant payments. So this is more practical in the mortgage world rather than the calculation of present values, since the cash flows come regularly, let's say monthly, quarterly, or semi-annually, or also annually. So for us to be able to calculate the present value of an annuity, use a different formula from the one earlier discussed. So this formula is as indicated here below. Now let's do a practical example of the present value of an annuity. So how much should an investor pay today for a real estate investment that will return 500,000 at the end of each year, 6 years, assuming the investor desires an annual rate of 6%. So for this, you can go back to Excel. Now, the important thing first be able to note is the annuity. This is the regular payment. So in this case, we're talking about an annuity of 500,000. Then the other important thing to note is the rate. So in this case, our expected rate or return is 6%, so which is 0.06. Then we also need to define the period. This is the compounding periods, total periods, or we can say, since it's annually compounding, say the years, which is 6. Now we need to calculate our present value. So for this, we'll use the following formula in Excel. So we'll write is equals PV, then brackets, then take the rate, comma, the number of periods, comma again, and the repayments, which are the annuities. With that done, you can put in a comma, you can close the brackets and press enter. So this is a present value. So you can see automatically it has brought it in dollar format currency. So if you're not calculating in dollar format, you can simply return it back number format. Now, also an important thing to note here, you find that it has a negative. The meaning of this negative in accounting means a negative cash flow. We're assuming the amount which we'll put in is 2.4 million 58,662. That's the present value of this particular real estate investment. Now let's look at the future value of an annuity. So for the future value of an annuity, this refers to the future amount which you receive after regular payments which earn interest over a set period of time. So this formula is also different from the earlier formula on future value, since unlike the first formula where an initial amount was invested and earned interest over a period of time, in this case a regular amount of payment is being done, let's say monthly, quarterly, semi-annually, or annually. Then you receive a compounded amount at the end of the period. So the formula of calculating the future value of an annuity is as indicated here below. So now let's do a practical example on future value. How much should an investor expect in the future from a real estate investment that will return 500,000 at the end of each year for 6 years, assuming the investor desires an annual rate of 6%. So we'll go back to Excel. So first, we need to capture the annuity, which is 500,000. Then the rate. The rate again is 6%, 0.06. And then the period. which is years. So for example, we are expecting the end of 6 years. So now future value. So for us to calculate the future value, we'll use this formula. Is equals FV, then the rate, number of periods, which is 6, and the annuity amount, or rather the regular payments. And with that, press enter. So the future value here is 3.487 million. So in the case that you don't want to receive this amount as a negative, you can simply add negative sign before the formula, or have your annuities as negatives. So there you go. And also, if you're not working with this currency, you can leave it as a number. With that being said, now you can easily calculate both the present value of an annuity and the future value of an annuity. Another important thing to note is you also need to have the ability to calculate the annuity or the regular payments if you have an idea or you know the future value. So for example, you can know that you have a bulk payment which is due in around 5 or let's say 10 years. So you need to invest this money or deposit it regularly at the end of each year, for example, into a certain account which you're earning a set amount of interest, and be able to raise the exact amount at the end of this period. So the way we do this is you need to go back to the formula where you are calculating the future value. So for you to get the future value, you multiply the annuity times the future value interest factor of an annuity. In the case that you want to get the annuity now, you simply divide the future value by the future value interest factor of an annuity, as indicated the formula here below. Of calculation of an annuity about the future value. Assume we have 3 million shillings or US dollar debt that must be repaid in one lump sum payment at the end of 5 years. If the interest rate is 10%, how much will each annual payment be? So that by the end of the 5 years, you have the 2 million which is required. So for this, let's go into Excel. So first, we already have our future value, which in this case is 2 million. Then we also have our rate, which in this case is 10%, which is 0.1. And we also have the period, number of compounding periods, which in this case is years, is 5. So for us to get the annuity of the regular payments towards our investment, we need to use the following formula. So it's equals to PMT brackets. So first the rate, then number of periods, then in this case the present value is 0. So in some cases, you have the present value already and you're trying to calculate the monthly repayments. So for our case, here will be 0. Then the future value will be 2 million. Then you close the brackets. Then press enter. So this is the monthly payments to the investment for 5 years for us to be able to raise 2 million shillings at the end of 5 years. Now let us look at internal yields, or what is commonly referred to as internal rate of return on investment. So for instance, if today you purchased a piece of land, let's say for 100 shillings, and then you end up selling this land for 500 Kenya shillings at the end of 5 years. So the internal rate of return is the rate applicable throughout this period of time, which you will have earned on your initial investment. So this is referred to as an investment with single receipts. So in this case, during this period of time, you haven't earned anything. So basically, you just spent to purchase, and then at the end of a certain time period, you've earned, let's say by selling or through other means. So the formula of calculating this is in relation to how we earlier calculated the future value of single receipts. So here we're trying to establish the effective rate which would have been applied to the present value for us to get the desired future value. Let's have a practical example of calculation of the internal rate of return with single receipts. So assume you're an investor with an opportunity to today buy an unimproved 1 acre plot for $5,000, 639. This plot is expected to appreciate in value and to be worth $15,000 after 7 years. What investment yield will be earned on the 5,639 investment in the property if it were made today, held for 7 years, and sold for $15,000. So to do this in Excel, we'll first need note the initial investment. So another important thing to note when calculating the internal rate of return, for any cash flow which is going out will be indicated as a negative. For any cash flow coming in will be a positive. So in this case, the cash going out as an investment is 5,639. So this is in dollars, okay? So for example, just leave it as a number format. Then at the end of year 1, how much will you receive? So in this case, it's 0. Since the property is not earning you anything. And at the end of year 2, it's also 0. So this trend will continue up to year 7. So to make our work easier, let's simply drag this up to year 7. So at the end of year 7 is the only time which you will earn $10,000. So for this period, you'll be earning 0 from investment. So now let us calculate the IRR. So the IRR is usually calculated as a percentage, as an annual percentage. So in our case, we are working with months, we'll have to multiply it for us to get the annual rate. But now for this example, since it's already in years, we'll simply use the following formula. Is equals to IRR into brackets. We take this range of the cash flows. And with that being done, simply press enter. So now we can simply see that our IRR for this particular investment would be 15%. So now let's look at determining yields or internal rate of return in investments where the yield is in relation to an annuity. So as you can recall, an annuity was described as regular payments over a set period of time. So for this case, we'll still use the same formula which applies in the future value of an annuity, or the same formula which applies in the present value of an annuity. So with that being said, we'll be able to look at a formula, or rather a practical application of this. So now let's look at a practical example of calculation of the internal rate of return for an annuity. So assume an investor makes an investment of $1,593 US and will receive $400 at the end of each month for the next 20 years. What annual rate of return compounded monthly will be earned on the 51,593? So in Excel, we need to note down these following figures. So first, we note our present value. So the present value is the amount which is being put in today. And this amount, as the investment, is 51,593. That's the present value. Then you will receive 400 at the end of each month for the next 20 years. So also an important thing to note, this present value, since it's an amount being invested today, it should be a negative. Let's put it as negative. Then our monthly income, which is the annuity, in this case, will be 400. Okay, and the period. So in this case, since it's being compounded monthly, so we need to get the total number of months, which is 20 times, which is 240. Or rather, even for better understanding, let's just have the years here. Since it's 20 years, and calculate the months. So that's this times we have 240. We can be able to calculate the internal rate of return using the following formula. So here we write rate first, then is equals to rate into brackets, then select the total number of periods, then comma. After that, write in the annuity amount, then comma, and finally the present value. With that, then close the brackets and press enter. Now you'll have calculated the monthly compounding rate. What we need then is to get the internal rate of return, or the yield, which is an annual rate. So for that, we'll have to multiply the monthly rate by 12. So here below, let's write now the IRR, which is equals to the monthly rate multiplied by 12. Now you can see the IRR is 0.07, which is 7%. And also note that for us to enhance our accuracy, we have to put this, or rather round it off to at least 2 decimal places, because in the first instance you could have noted that the monthly rate was 1%, but that wasn't accurate since it was an estimate. Congratulations on reaching the end of the first chapter, which has been the overview of real estate finance and investments. At the end of this course, there is an assignment and a quiz. You can attempt this, whereby you'll be able to get real-time results and solutions to the problems. This will enable you cement the knowledge which you've learned in this session, since this will be the critical knowledge required in the later chapters. Also, a link will be provided to the Excel sheet which was being used as a demonstration for problems in this particular chapter. See you in the next session, where we'll be able to look at mortgages.